Okay, as we've been talking about in class, atoms are really small, but it's important that we talk about ways in which we can compare those atoms experimentally. So it's not enough just to know how much an atom weighs, or more appropriately, what its mass is. We need to know how many we have. So if I have one boron atom, okay, and I'm reacting that with oxygen atoms, I need to know how many boron atoms I have and how many oxygen atoms I have. But the problem is atoms are too small to work with. So instead of working with one boron atom or one oxygen atom, we work with 1 mole of boron and 1 mole of oxygen. Mole is a very large number, 6.02 times 10 to the 23rd, a number we would never be able to count. However, we do know how much 1 mole weighs, and that's that number there. It's the atomic mass, but I really like to refer to it as the molar mass, okay, because that really becomes the number that is useful to us. So in boron's case, 1 mole of boron has a mass of 10.8 grams per every mole. That means if I have 10.8 grams of boron, I have exactly 1 mole of boron. Okay, oxygen has a molar mass of 16.0 grams per every 1 mole. So if I have 16 grams of oxygen and 10 grams of boron, I have the exact same number of boron and oxygen atoms, 1 mole. So when I do that, then I can react them and I can go, whoa, boron and oxygen fit together like this. It's not correct to say if I have 1 gram of boron, I then have 1 gram of oxygen, because oxygen just is a heavier atom. 1 gram of oxygen is less total oxygen atoms. 1 gram of boron is more boron atoms. So we need to be talking about a common unit of measurement, and that unit of measurement in chemistry is the mole. Now, very rarely do we have 1 mole. Sometimes we have a fraction of a mole. Sometimes we have much more than 1 mole. And because of that, we need to be able to do a quick proportion or conversion back and forth. So let's do a couple of examples of those. So let's say the question was, if you have, let's say, 8 grams of CO2, okay, how many moles of CO2 is that? Okay, so the first thing we want to do is get the molar mass. Okay, this is our basic unit of comparison, basic unit of measurement here. So the molar mass for CO2 is made up of 1 C, which we know is 12, and 2 oxygens, which we know are both 16, and we can add those up. So I'm doing a compound here because it's just a little bit more complicated. If you had an atom, the molar mass of that atom is just the atomic mass of that atom. But in a compound, you add them up. So it was confusing people in class, this 2 idea, but I want you thinking about 1 CO2 mole. Just 1 CO2 mole has 1 carbon and 2 oxygens built in. 1 Ramsey has 2 arms. If I'm talking about 2 arms, that's different. But if I'm talking about 1 Ramsey, I'm going to get the mass of my arms, my legs, my head, etc. Okay. So when I add these up, I have 44 grams per every 1 mole. That means 6.02 times 10 to the 23rd units, molecules, compounds, whatever you want to say, of CO2 has a mass of 44 grams. Okay. Well, if 44 grams is 1 mole, 8 grams is how many moles. Okay. So we cross multiply. So 44 times x is equal to 8 times 1. And then when we do that out, we simply do 8 divided by 44, and I get 0.18. I'm not big on rounding. 0.18. I'm sorry. 0.18 moles. Let's do another problem in the reverse direction. Let's say now I have 0.25 moles of H2O has what mass? Okay, and you might know that mass, I know it's grams. So the first thing I'm going to do is get my molar mass. Okay, and in order to do that, I know that hydrogen has mass of 1 gram per mole, and there's 2 of those, and oxygen is 16. So if I add those up right here, I get 18 grams per every 1 mole is equal to, okay, well, I want to know what mass, so how many grams per 0.25 moles? Very easy. Then I cross multiply. So when I do that, I do 0.25 times 18 equals x divided by 1, and I end up with 4.5.